Greetings, mathematicians. Welcome back. So we're going to be taking a look at exploring how to look at both slope and concavity of parametric equations. So let's go ahead and first start by figuring out, because we want to find out what is the slope and concavity at a specific point. So I'm eventually going to have to figure out, well, what is time at that specific point? So the first thing I'm going to do, however, is I'm going to figure out what dy dx is, and then I will find the second derivative, and then we'll look at it at that specific location. Okay, so that's the location right up here. Now, our graph tells us in this diagram that we should get time is equal to 4 when we eventually solve for that. But let's show how we would do that if we weren't given that information. So we are told that x equals the square root of t, so dx dt is going to be 1/2 t to the negative 1/2 power. dy dt, which for y is equal to 1/4 times t squared minus 4, that is going to be 1/4 times 2t to the first power. And that gives us, I'm going to simplify it just because we're going to utilize this, that is going to give me a value of 1/2 t. All right, so now we're going to find dy dx. Okay, our first derivative. So dy dx is known as dy dt divided by dx dt. So I am going to take my 1/2 t, which is my dy dt, and I'm going to divide that by my dx dt, which is, if I simplify that, that becomes 1/2 root t. So 1/2 root t. Okay, now I'm going to do a little bit of simplification for this. And so this would be equivalent to 1/2 t times 2 root t over 1. And so 2 times 1/2 cancels out. And this is t to the first times t to the 1/2. So that gives me t to the 3/2 power. So that's my first derivative. Okay, now let's go ahead and let's find our second derivative. So the second derivative of y with respect to x is going to be the derivative with respect to t of dy dx divided by dx dt. And if you're confused about that conceptually, in one of my previous videos, I did take a look at why. Hopefully we can develop some conceptual intuition and understanding about why that formula makes sense. So let's go ahead. We know that we have t to the 3/2 is our first derivative. So that's this guy right here. So t to the 3/2. So I'm going to take its derivative with respect to time. When I do that, the derivative of t to the 3/2 would be 3/2 t to the 1/2 power. I'm going to then divide that by dx dt. And dx dt was 1/2 t to the negative 1/2 power. All right, and so if we go ahead and do some simplification there, well, 3/2 divided by 1/2 is the same thing as 3/2 times 2. And t to the 1/2 divided by t to the negative 1/2 gives us a value of just t, because our exponent would be 1/2 minus a negative 1/2, which gives us 1/2 plus 1/2, which is a whole factor of t here. So our final result is that this second derivative should be equal to 3t. All right, now, if I'm trying to find the slope at the point 2,3 and the concavity at the point 2,3, I need to know at what time am I located at the point 2,3. So let's go ahead and figure out the value of t for when we are at the location 2, 3. So we want to know our t value is equal to what number. So I am going to set my x parametric equation equal to that the x value. So 2 is equal to the square root of t because x equals root t. And I know that y equals 1/4 t squared minus 4. So therefore 3 is equal to 1/4 times t squared minus 4. Now, I'm going to go ahead and solve for the value of t. So I get t is equal to 2 squared, which is 4. And I'm going to multiply both sides by 4. So I get 12 is equal to t squared minus 4. And so t squared is equal to 16. Now, I got two values of t, of -4 and +4 for when the y value is associated with a value of 3. Now in this case, we don't have to worry about time equals -4 because that's not in the domain for the x parametric equation. We need to only consider values that are greater than 0 for time elements. And so our single solution for this would be t equals 4. Now that we know the value of t, we can figure out what's the slope at that time, and we can also figure out what's the concavity for that value of t as well. So when t is equal to 4, we know that dy dx must be equal to 4 to the 3/2 power, which would be the same thing as the square root of 4 cubed. So the square root of 4 is 2, cube that is 8. So my slope there is 8. And from our diagram, hopefully that seems reasonable in terms of, yeah, our slope, it's a positive number, it's rather steep, it's greater than 1. And then now, if we're going to look at our second derivative of y with respect to x is going to be 3 times 4, which is 12. And since that value of the second derivative was positive, that tells us that our function is going to be concave up. So our plane curve here is going to be a concave up location at the coordinate 2, 3.